All right, welcome back. In this video, I'll be talking about sleep and the stages of sleep. So first, for the definition of sleep, it is a state marked by relatively low levels of physical activity and reduced sensory awareness that is distinct from periods of rest that occur during wakefulness. And why do we sleep? That's the age-old question. One adaptive function of sleep from an evolutionary point of view is that sleep is essential to restore resources that we expend during the day. And although there isn't a lot of research to back this up, it is an evolutionary point of view. But please remember that this is a theory that does not have a lot of research to back it up, which is important to realize when we're learning subjects like this. And another evolutionary hypothesis of sleep holds that our sleep patterns evolved as an adaptive response to predatory skills, which increase in the darkness. And so we sleep during the nighttime in order to avoid these predators and reduce our chance of harm. But again, there's very little research in order to not only conduct a study like this, but there's very little research to back this up. And there seems to be no universal adaptive function for sleep, but sleep does provide some benefits for us. Another theory regarding why we sleep involves sleep's importance to our cognitive function and memory formation. Sleep has been associated with other cognitive benefits, such as research indicates that sleep helps with creative thinking, language learning, and making decisions. And sleep seems to be more of a function of consolidating our memory and improving our cognitive functioning. And if you didn't know already, we experience sleep in different stages, which I'll go over now. And first, sleep can be divided between REM sleep and non-REM sleep. REM sleep, or rapid eye movement sleep, is characterized by darting movements of the eyes under closed eyelids. And brain waves during REM sleep appear very similar to the brain waves when we are awake. And non-REM sleep is subdivided into 4 stages, which are distinguished from each other and from wakefulness by characteristic patterns of brain waves. So there's different kinds of brain waves within these 4 stages. The first 4 stages of sleep are non-REM sleep, while the 5th and final stage of sleep is REM sleep. And so here's an example of the different waves for sleeping patterns, which I'll discuss. And these brain waves are measured by EEG readings of electrical activity going on in your brain when we're asleep. So the stages of sleep occur with being awake first, and then the first stage of non-REM sleep is stage 1. And then we have stage 2, stage 3 and 4, and then the last stage is REM sleep. Moving forward, the first stage of the sleep cycle is the transitional phase between wakefulness and starting to go to sleep. And this is when we start to drift to sleep. So we transition from being awake to this first stage of non-REM sleep. And this occurs when our heartbeat and respiration slows down, our muscles start to relax. And this stage includes alpha waves, which is brain activity waves measured with EEG. And these waves have a low frequency and high amplitudes. So this means that the waves and the spikes occur at a low frequency, but they have high amplitudes. So they have high peaks. Similar to this example here. So there's a low frequency and a higher amplitudes. And then in stage 1, or stage 2, our next stage of sleep, our body moves into a deeper relaxation, and our brain produces theta waves, which is an even lower frequency and even higher amplitudes of brain waves compared to alpha waves. And in this stage, these theta waves are interrupted by sleep spindles, which is a rapid burst of higher frequency brain waves. Notice there's more brain waves occurring here than along the spectrum here. So it's a higher frequency, and it may be important for memory and learning. And also a K-complex is a very high amplitude pattern of brain activity that may occur in some cases in response to different environmental stimuli in which we're asleep. And this is what kind of looks like a K-complex in the sleep spindle. So we have these really high frequency peaks, and then a K-complex is a really large amplitude that rises and goes down and then returns back to baseline. This is an example of a theta wave. So there's even less of a frequency occurring compared to stage 1, where we had more frequency of waves. And these waves in the theta waves are much higher and have higher amplitudes compared to the alpha waves. Then for stage 3 and 4, our last stage of non-REM sleep, this is a really deep sleep and a slow wave sleep. And these include delta waves, which have a really low frequency and higher amplitudes than the previous two kinds of waves. And it's really difficult to wake up during this stage. And if we experience alpha waves in these stages instead, then we're not really well rested, regardless of how long we end up sleeping. And this is an example of a delta wave. So as before, we saw many waves with alpha waves, and then maybe just 3 for theta waves. And this is an even lower frequency of waves and even higher amplitudes, similar to as you see here. And then our last stage includes REM sleep, or again, rapid eye movement sleep. So this occurs when we have rapid eye movements underneath our eyelids while we're sleeping. These brain waves are similar to the brain waves when we are awake, which is really interesting. And this occurs, dreaming occurs when we enter REM sleep. This stage also includes muscle paralysis of our voluntary muscles, so our arms, legs, and other major muscles. And this stage also includes an REM rebound, and if people are deprived from REM sleep for a while, and then they sleep without any disturbances, then they go directly to the REM sleep stage, passing these previous stages. And REM sleep is thought to play a part in learning, memory consolidation, and emotional processing. And I mentioned that REM sleep is when we have our dreams, and the meaning of dreams really varies across different cultures and different time periods. But one theory from our pal Sigmund Freud was convinced that dreams represented an opportunity to gain access to the unconscious And by analyzing dreams, he thought people could increase their self-awareness and gain an insight to help deal with certain problems that they faced. And he stated that dreams have manifest content, which is the actual content or storyline of a dream, and also latent content, which refers to the hidden meaning of a dream. Another theorist was Carl Jung, and he believed that dreams allowed us to tap into a collective unconscious, which is a theoretical repository of all the information that he believed was shared by everyone. And according to Jung, certain symbols in dreams reflected universal archetypes with different meanings that are similar for all people, regardless of their culture or location. Also, Rosalind Cartwright believed that dreams reflected our life events that are important to the dreamer. And unlike Freud or Jung, Cartwright's ideas about dreaming have found empirical support. And she and her colleagues have published a study in which women going through a divorce were asked several times over a 5-month period to report to the degree to which their former spouses were on their minds. And these same women were awakened during REM sleep in order to provide context to what they were dreaming about. And there was a significant positive correlation, so there was a significant positive relationship between the degree to which women thought about their former spouses during waking hours and the number of times that their spouses appeared in their dreams. And so this was a really interesting finding by Cartwright. And then another researcher was John Hobson, who has done research on lucid dreams, which are dreams in which certain aspects of wakefulness are maintained during a dream state. And in a lucid dream, a person becomes aware of the fact that they are dreaming and become conscious of the fact that they're dreaming, and they can control the dream's content. And so it's not exactly sure what a dream's function is, or why dreams exist, or why we dream, but it may help consolidate memories and consolidate life events that are important to the dreamer.